Good afternoon and welcome to the Pembina Institute's webinar, Going Electric, How Urban Delivery Fleets in the GTHA and Beyond Can Make the Shift. For those who are unfamiliar with our organization, we are a national not-for-profit think tank with a mission to advance a prosperous, clean energy future in Canada through credible policy solutions that support communities, the economy, and a safe climate. This is an exciting time for this discussion in the midst of a renewed climate plan for Canada and significant investments and interest from all sectors to drive down transportation emissions. And one way of doing that is through zero-emission vehicles. On top of this, our cities are changing and growing, and the number of delivery trucks and vans that are operating in our streets is also growing. So now is the time to consider what the proliferation of delivery trucks is doing on our streets, the air that Canadians breathe, and the impact that those vehicles have on our global warming. That is why the Pembina Institute has started a new business coalition, the Urban Delivery Solutions Initiative, that works with businesses and organizations to reduce urban freight emissions. And so we're excited to hear from those businesses today at our panel. So thanks once again for joining, and I'll pass you over to Maddie Ewing.
Amazing, thank you so much for those opening remarks, Carolyn. I'd just like to take a quick moment to thank our partner on this project, the Atmospheric Fund. Their generous support allowed us to conduct this research over the course of the past year. So my name is Maddie Ewing, and I'm a transportation analyst at the Pembina Institute, and I led our recent work here on urban delivery electrification in the Greater Toronto and Hamilton area. So here's a quick outline of sort of what the next hour will look like. So I'm going to start off by providing you with a quick overview of urban deliveries in the GTHA and why EVs are a suitable low carbon alternative. I'll provide you with a quick intro to our latest publications and highlight some of our key research findings. We'll then dive into a panel discussion with our guest speakers. So who are our guest speakers today? Well, we have Mary de Guzman joining us from Purolator. Mary's the head of corporate social responsibility and sustainability. Purolator is working actually right now to be recognized as the greenest courier company in Canada as they work towards being carbon neutral by 2050. Also joining us on the panel today is Sid Kakadar, an electric vehicle solutions engineer at Geotab, a telematics company. Sid helps fleets transition to EVs and operate efficiently by leveraging data and analytics. So we're going to kick things off here with a quick audience poll, just to get you sort of in the headspace of urban deliveries and e-commerce. So I just want to put it out there and ask the audience, on average, how many package deliveries do you personally receive to your home in a given week? So I'll give Stephen a second there to bring the poll up, and you should all have access to that now. So you can select none, 1 to 2, 3 to 4, or 5 or more. And I know this, if you're anything like me, this might be a little difficult to answer because I find deliveries do come in waves. So on one week I might have, a few deliveries. The next week I might have none, but just maybe consider on average, what does that look like? So we'll just give you another 20 seconds or so to respond there. All right, and how are those answers looking? Let's see. Okay, so on average, you've got about 1 to 2. A bunch of you are in the 3 to 4 range and a few in the 5+. Surprising amount of you actually in the none. But I think, I would assume as you think about this, your demand for local deliveries has probably increased significantly over the past year. So given these responses, Stephen, if we can move over to the slide deck there, I think, this image that's about to appear on the slide probably is a very familiar sight for most of you. Since the start of the COVID-19 pandemic, Canadians living in cities have become increasingly reliant on home deliveries, whether it's groceries, clothes, or furniture for your new home office. However, as demand for home deliveries surges, now is the time to consider the impact these vehicles are having on climate change and local air quality. As I previously mentioned, I'm speaking to you from the GTHA, which is home to one of the fastest growing metropolitan regions in Canada and the US. Greenhouse gas emissions from transportation represent 1/3 of the region's total emissions. And as municipal government, businesses operating in the area, and other key stakeholders look to tackle emissions from transportation, it's critical that the commercial vehicle sector is not overlooked as activity from the sector is growing. So e-commerce sales are soaring. In 2020 alone, Canada Post reported a 54% increase in Canadian retail e-commerce sales. Consumers are demanding faster and faster deliveries and expecting it for free. But most of the vehicles making last mile deliveries are internal combustion engine vehicles. Next slide, please. So the greenhouse gas emission benefits of EVs are likely to be substantial here in the GTHA because the carbon intensity of electricity is relatively low. Last mile urban delivery vehicles are particularly well suited for electrification due to the fact that they travel short distances on any given day and often return to base, so they can easily take advantage of depot and overnight charging, and they don't have to sort of worry about that range anxiety and the availability of public infrastructure. So for this reason, we see urban deliveries as the next wave of electrification. There are already 10 battery electric cargo van and step van models available here in Canada, including those offered by Automakers and Lightning Electric, and 2 others have been announced from Ford and GM. However, to our knowledge, few full-speed EVs for urban deliveries have been deployed across Canada, and none have been deployed here in the GTHA. Next slide, please. So questions remain on how businesses can scale up and integrate EVs into their urban delivery fleets. What will this transition cost? What is the magnitude of greenhouse gas emission reductions that a business can expect to see? What steps do businesses actually need to take to deploy EVs here in the GTHA? And how can different levels of government support this transition? Next slide, please. So over the past year, we've worked hard to answer all of these questions. These 2 reports are the culmination of our research, and you can actually download them in the GoToWebinar sort of pull out here that you should have access to. So the report on the left, Making the Case for Electric Urban Delivery Fleets in the GTHA, details the costs, energy demands, and environmental benefits of electric cargo vans. And it's the key findings of this report that I'm going to go walk you through over the next 5 or so minutes. Meanwhile, the report on the right, Making the Switch to Electric Urban Delivery Fleets in the GTHA, is a step-by-step action plan for commercial electric vehicle deployment. And we'll be walking through what this process looks like, some of the opportunities and barriers and key steps with our panelists during the panel discussion portion of today's event. Next slide, please. So to quantify the various costs and benefits of EVs, we collaborated with researchers at the National Research Council. Together, we developed a model that incorporates data we obtained from Geotab, which provided various statistics on the real-time operation of vehicles performing door-to-door deliveries in the GTHA. It also incorporates insights from several prominent businesses on their operations and logistics. Using this data, we created 13 drive cycles that reflect a range of scenarios. So we created a baseline scenario that reflects average conditions. We also developed scenarios for a high number of stops, a vehicle with a heavy payload, congestion, cold weather, and others. And multiple factors were combined into a single scenario that was designed to test the maximum energy demands of EVs performing deliveries in the GTHA. So we simulated the operation of a manufacturer agnostic cargo van, electric cargo van, within these drive cycles to determine the expected EV energy consumption, charging infrastructure requirements, fuel costs, and greenhouse gas emissions. We compared our results to those of an equivalent ICE vehicle to determine expected fuel cost savings and greenhouse gas emission reductions. Next slide, please. So it's important to know a few of the key inputs to this model and our scope of research. So we looked specifically at cargo vans belonging to the class 2B or 3 weight class. We looked at those performing door-to-door deliveries here in the GTHA. And based on feedback that we received from several prominent businesses, it was assumed that EVs would return to their home base at the end of each shift and have several hours of downtime overnight. So this meant that we could explore what would be needed to support depot charging rather than relying on the availability of public charging infrastructure, which is currently fairly limited. Next slide. So it turns out that urban delivery routes in the GTHA are actually quite short. So vehicles only travel about 60 kilometers per day on average. To satisfy the energy requirements associated with the baseline scenario, the one that reflects the average conditions, only approximately 10 kilowatt hours of power is required. Meanwhile, under conditions that maximize energy demands, so the scenario that looked at an above average route length with a higher number of stops, a higher average speed, a heavier payload, and cold external temperatures, energy demands climb up to 43 kilowatt hours. So these energy requirements are actually notably low, considering the fact that currently available or announced electric cargo van models have battery capacities as high as 105 kilowatt hours. In fact, all currently available or announced EV cargo van models can satisfy these energy requirements. Next slide, please. So due to the relatively low energy demands of EVs performing urban deliveries, and because we heard from businesses that they would have ample time to charge overnight, we explored the possibility of using level 1 or level 2 chargers to satisfy charging requirements. So these level 1 and level 2 speeds charge at relatively low speeds in comparison to, say, a DC fast charger, which is one that can charge a passenger vehicle in about 30 minutes. So across all scenarios explored, level 1 or level 2 chargers provide sufficient power to charge vehicles overnight. For the baseline scenario that reflects average expected conditions, EVs can actually get away with using level 1 charging, which is equivalent to plugging the vehicle into a standard wall outlet. This came to quite a surprise for us. So at this speed, it only takes EVs 7 hours to reach a full charge. Under some of the more energy demanding conditions, however, it is expected that level 2 chargers will be needed. So under the high energy demand scenario, EVs take about 6.5 hours to charge overnight using level 2 chargers. These findings are significant in that they demonstrate that expensive DC fast chargers that can go for $100,000 a piece are likely not required for businesses conducting urban deliveries in the GTHA. Next slide, please. So importantly, our research has demonstrated that under baseline scenario conditions, businesses can expect to see fuel cost savings of approximately $3,800 to $4,400 per year when they switch from an internal combustion engine vehicle to an EV. And as expected, we also find that there are significant opportunities for greenhouse gas emission savings. Over the course of a year, 12 tons of CO2 equivalent can be avoided by making the switch to an EV for urban deliveries here in the GTHA. Next slide, please. But many businesses will want to know whether or not these fuel cost savings are enough to recover the higher upfront capital cost of EVs. So the chart on this slide compares the cost to own an EV in comparison to an internal combustion engine vehicle over the course of 20 years under the baseline scenario conditions. So taking into account the average upfront vehicle costs, the annual maintenance costs, fuel costs, and charger costs, we find that Class 3 electric urban delivery vehicles in the GTHA are expected to have an average payback period of 7 to 8 years for level 1 and level 2 charging, respectively. So in other words, the higher upfront capital cost of an EV are recovered by the fuel cost savings in 7 to 8 years. And this actually falls within the vehicle ownership cycle of all of the businesses that we engaged here in the GTHA. Next slide, please. So our study demonstrates that EVs present notable benefits for businesses conducting urban deliveries in the GTHA. Across all of the 13 scenarios explored in this study, EVs are expected to be relatively easy to charge, cost-effective, and will reduce emissions significantly in comparison to ICE vehicles. But I would like to take some time to acknowledge some of the limitations of our analysis. For instance, our study did not include the cost of infrastructure or grid upgrades, which can be significant. However, not all fleets will need to undergo infrastructure upgrades, and for those that do, we expect costs to vary. Furthermore, I'd like to acknowledge the variability of electricity costs. So these costs are dependent on charging schedules, fleet size, existing facility electricity requirements, among other factors. And so it's expected that these costs will vary significantly from one business to another. So while our results are promising, it's important to keep in mind that they're reflective of average conditions, and businesses may want to take the time to conduct their own assessment, similar in nature to what we've done here, that is representative of their specific operating conditions. So I'm now going to ask my panelists to join me on video. Just a heads up that we will be leaving about 5 to 10 minutes towards the end of our discussion for an audience Q&A. So if you do have a question, please feel free to type it into the chat box. And as our panelists get settled on screen, we'd like to just show a quick video of some EV deployment efforts that are already underway at Purolator. Amazing. Great and wonderful, Mary and Sid, to have you both here. Thank you so much for joining us. And Mary, so it's fantastic to see some of these EV deployment efforts already underway at Purolator. And so while that video showed us some of the sort of low speed EVs that you're piloting here in Toronto and Montreal, I should let the audience know that you've recently announced the purchase of full speed EV step vans that will be deployed in Vancouver. So, just quickly, what has been Purolator's motivation to adopt EVs?
Well, thank you for having me, Maddie. Purolator is a leading integrated freight, package, and logistics solutions provider in Canada. And we already have a fleet of hybrid electric vehicles and are now looking at other sustainable alternative transportation modes, including electric low-speed vehicles, electric cargo bikes, and like you mentioned, our fully electric vehicles. And from our annual greenhouse gas inventory report, that we've been producing for the last 13 years, we identified that our commercial curbside vehicles represent the majority of Purolator's Scope 1 emissions. So our owned ground fleet accounts for about 30% or 111,000 tons of carbon dioxide emission equivalent. And so what we see is the benefits of our green fleet vehicles. Like they include things like, our urban centers have lots of urban congestion and lack of parking. So our e-bikes help with traffic congestion and getting into areas with no or limited parking. And we also, this helps reduce traffic congestion, noise and air pollution. It's sustainable, it's quiet, and produces no tailpipe emissions like you saw in the video. It also reduced our operating and maintenance costs, like you mentioned, and we're seeing, compared to traditionally fueled vehicles, a projected 85% reduction in those operating and maintenance costs. And what we're also seeing is reduced greenhouse gas emissions. So these electric vehicles we've introduced in our fleet can replace an average fuel truck and provide the same operating performance and reduce greenhouse gas emissions by approximately 24 metric tons per year. So, in the case of our e-cargo bikes, they also improve courier capabilities to deliver in restricted city areas. And again, the ability to improve customer service and delivery experience in the congested downtown core areas.
That's great to hear, and it's exciting to hear about the many different sort of efforts that are underway at Purolator. But what I'm hearing is that for a company like Purolator or other courier companies where urban deliveries are your bread and butter, a switch to EVs presents a huge opportunity to get at the vast majority of the Scope 1 emissions, which is incredible. So for fleets and businesses that are looking to deploy EVs and are considering making the switch, what are some of the different options that exist? So what are the different types of EV models available, and some of the pros and cons to each of those different options?
Right, so we're seeing a lot of different like OEM solutions coming out that are turnkey. What we introduced in our Richmond fleet was we have a Ford F59 stripped chassis that's outfitted with an electric conversion kit provided to us by Motive. So, you can do these, outfitted, tailored models for your organization. And so the pros, these things are available today. We're seeing a lot of OEMs, like you mentioned earlier, a lot of announcements coming out from GM and Ford later on this year. Some of the cons that we've encountered at Purolator, some issues with parts not syncing up properly. For example, in our new electric delivery vehicles that are built, like I mentioned, on the Ford F59 platform, there was a delay in the delivery of the product to us because the ABS program had changed by Ford and didn't sync with our EV conversion kit. And I know Sid can probably relate to some of the issues with telematics.
Thank you, Mary. Yeah, to add to everything you said, I think you covered the types of vehicles and their pros and cons really well. I'd like to add with the scenario where a fleet looks to deploy a retrofitted, upfitted vehicle. You highlighted that yes, you could run into issues with parts syncing up correctly. To add to that, there is an adjacent con that goes with parts not syncing properly, which is data collection. So when you do have a vehicle that on the system level operates as one vehicle, but underneath the hood, you have two or three different subsystems working in sync together to make that happen. When they do originate from different manufacturers, it becomes hard to retrieve data from them from a telematics perspective. Not impossible, just slightly more harder. And with EV deployment in this space, especially for medium and heavy duties as a whole, utilizing data to stay on top of ensuring your fleet is operating efficiently as well as charging efficiently, data enablement becomes a key factor. So that is just something that fleets must take into consideration when looking to adopt EVs that are retrofitted in nature.
Yeah, absolutely. I think, Sid, you're right. That data point is so important. I mean, I've heard of instances where an EV is plugged in, but is in fact not plugged in properly and not charging, and that can be, disastrous for a business that needs to deploy that vehicle in the morning or something, or within the hour. So I'd like to get at, what are some of the most critical elements of an EV deployment strategy? So as businesses start to think about what this is going to look like, they know what vehicle options are potentially available to them. What other things do they need to consider in that strategy? And so, Mary, why don't we start with you here?
Sure. So like Sid mentioned, having a data-driven approach to decision-making is key, and that will help any organization get buy-in from their senior leadership. Our first, point was to make sure we piloted a few of these vehicles first. And then the next, critical element is making sure that you involve a number of your key internal and external stakeholders. In our case, including a network strategy, as it may not be possible to implement a fully EV fleet in some jurisdictions because it may be limitations to the grid capacity. So these are some key things to think about.
And so, do you have anything to add on to that?
Absolutely. So Mary hit the nail right on the head with taking a data-driven approach. When you are looking to deploy EVs or are looking to operate EVs efficiently, data just becomes indispensable. So with that, what you really want to take into consideration in your EV deployment strategy as a fleet is vehicle selection and duty cycle selection. So they both go hand in hand. You're not just limited to thinking about this in the sense that, hey, I need to get an efficient EV that's cheap. You're also looking at how am I deploying this EV, in what duty cycle am I using it? Because the ROI on that EV changes significantly depending on the type of duty cycle it is deployed in. So thinking about how can I modify my duty cycle to make sure that I am getting a good ROI on that EV is a really good consideration for fleets to be thinking of as they look to develop a EV deployment strategy. A Geotab internal study showed us that 2/3 of light duty duty cycles yield a positive ROI, and there's no reason why that couldn't translate into medium and heavy duty electric vehicles. In conjunction with that, fleets must also think about charging considerations. So deploying a appropriate number of charging stations that go hand in hand with the number of EVs that they're looking to deploy. And something that might be not top of mind for them as they're looking to do this is you don't necessarily need a one-to-one correspondence between the number of EVs in your fleet and the number of chargers. With an optimized charging strategy, which is enabled by data and connectivity, you're actually able to charge your entire fleet by having far fewer chargers than you have EVs. So considering this along with developing a EV strategy is something I'd recommend for fleets. And once you do have those EVs in hand, you're operating them using data to set up the right types of KPIs, the right kind of indicators to ensure that yes, my duty cycles are being used as intended, my fleets are operating efficiently, my vehicles, my routes are being utilized as decided on paper and plan, is something that fleets must take into consideration when developing that strategy.
Absolutely. And I will note, Sid, I know you're biased in being a data person, but despite that bias, I totally agree. I think, you really do need to look at your numbers, you need to look at your operations, and that is critical to what's happening. So we heard in our research as well that one of the biggest things as well is starting early on this. So there's a bunch of unexpected hurdles that can come up along the way. And, you know, some of those things are like not being able to get the amount of electricity capacity at a site. So why don't we talk about some of those hurdles that can come up so fleets know what to expect maybe. So Mary, I know you guys have run into some of these issues at Purolator, so why don't you kick things off here?
Sure. Well, like I mentioned, you know, if there's a change in software programming, that definitely was a hurdle, an unexpected hurdle we encountered from our pilot. But you mentioned it, actually, Sid mentioned it too, with insufficient power to the site. You know, you may need to think about the requirement for transformer or grid upgrades. So depending on the amount of new load that you'll require when you put in charging infrastructure, you may need to consider having a new substation, a new transformer bank, a new circuit, or even higher voltage service. You know, at the very least, sometimes upsize wiring or cable to the site, or even reconductoring. So there's a lot of those things that, you know, just aside from selecting the right vehicle type for your operation and knowing which charger, you know, infrastructure to install, you also have to, you know, consider the utilities and what's available in the locations where you're going to be operating.
And so I think this is you know, something to note as well. It's engage your local distribution companies, get in touch with them. They are the experts on, you know, your capacity, your needs, what is possible. So reach out to them before you kind of get into this process and start deploying charging infrastructure. Because again, nightmare stories of people that go in and deploy some of this infrastructure before understanding how much power they actually have reaching the site and not ending up having enough. So, you know, Sid, does that resonate with you as well? Or do you have anything, other sort of unexpected hurdles that fleets should maybe be aware of?
Yeah, that 100% resonates with me. I think Mary covered it really well. The only thing I would add to that is when you're looking to charge, it's also important to take into account how many vehicles you charge at a given time, because you could run into an unexpected hurdle like running into demand charges, where you stack your load up on the grid really high because you're charging a number of vehicles and you have the facility itself drawing some amount of power. You could run into a threshold where your rates of electricity are really high, and that's something that fleets should definitely be cognizant of. And the only other one I'd add, and Mary touched on this at the beginning, was just the lead time for vehicles, because when you place an order, you might not get the vehicle exactly as you expect it to come in, and that's something that could manifest as an unexpected hurdle.
Yeah, I think this whole area of, you know, electricity infrastructure and engagement with local distribution companies is something that will be unfamiliar to a lot of fleets. This is kind of like a whole new part of your fleet and your operations that you need to consider. So we've talked about grid infrastructure upgrades, and I know those are really significant. Sid, you also touched on some of these demand charges and, you know, some of the, I guess, perhaps negative aspects of charging a bunch of vehicles in parallel. So there are certain charges on your electricity bill that are scaled according to your peak demand, such as, I think in Canada here, it's the delivery charges specifically and the global adjustment for Class B customers. You know, what can fleets do to avoid some of these costs, both sort of the grid upgrades, as well as some of those peak demand charges? I know these kind of go hand in hand in a lot of ways. It's all about managing that peak demand. So what can fleets do to overcome those hurdles? And Sid, why don't you kick things off here?
Yeah, absolutely. I was just waiting for you to say that. I want to say that with these unexpected hurdles, the best way to stay on top of them, to overcome them, is with data and connectivity. This is indispensable when you're looking to operate an EV fleet efficiently, as well as just transition to EVs. The best way to get around some of the charging hurdles is to put into place some managed charging, smart charging strategies. So this is where you have a number of EVs that are plugged in to separate chargers, but they're perhaps not all of them are drawing power at the same time and charging the EVs, or you have EVs that are plugged in at a certain time using one charger, and then someone manually goes in and shifts the charger to the next vehicle, making sure that the load on the grid is always within a certain threshold. This can be done manually, like I said, or in an automated fashion, depending on the types of vehicles and the types of charging stations that are available on site, and can save a large amount of money. Something that is an extension of this concept is you have something
And
called
before you actually get into that,
yeah.
I mean, for individuals that maybe don't know what smart charging looks like,
Mhm.
like how can you control that? You say you can automate it, but what does that look like actually?
Absolutely. So you need two key pieces. You need the vehicle and the charging station data to be in one system where you can basically toggle the charge on and off depending on certain KPIs. So if you look at what is my total load from my facility at the grid at this time, and you say, okay, I can maybe stack another vehicle's charging on top of this. You have chargers that are plugged into vehicles, and you toggle the charging on for vehicle 2 as well as vehicle 1, because your load on the grid allows for you to increase the number of vehicles you're simultaneously charging. You can also do this in a automated fashion where you set pre-configured charging schedules, and the charging station dispenses charge to specific EVs according to that charging schedule. This is when the charger is physically plugged in at the port, but there isn't charge flowing to the EV from the charging station throughout. So this can really be set up using the charging station and the vehicle to basically decide which ones need charging. Geotab's involved in a number of projects that allow for this sort of managed charging to take place.
I mean, I think thinking to sort of our results from our study where we found it's only about 10 kilowatt hours that an EV needs for any given day. I mean, you'd think there'd be huge opportunities there if all your vehicles have level 2 chargers, for instance, and you have a fleet of 50 vehicles. Say we found it takes about 2.5 hours to charge using those level 2 chargers. You can spread that out so nicely on any given night, and spreading across that peak demand over those vehicles to sort of reduce your overall cost and reduce that peak demand. I feel like there's, particularly for the urban delivery sector, there's big opportunities there to leverage this technology.
100% agreed. I think what I'd like to introduce in as an extension to that topic is something called vehicle to grid technology. So this is the concept where you have excess energy in your EVs at the end of your day that you didn't necessarily use, and you can, via the charging station, sell that energy back to the grid to basically offset any electricity costs that you might have. If there isn't a demand from the grid at the time, you could also use that energy, excess energy from your day, to power up the facility itself. And this is a very, very valuable and indispensable tool, because we're talking about, in the absence of connectivities, EVs could be a liability to the grid, but if they're all connected and they're operating in a fashion where you're exchanging energy back and forth with the grid, EVs could really be an asset, because you could run into scenarios where a few EVs in a fleet absorbed energy from the grid when it was advantageous to do so to stabilize the grid. Uh, so vehicle to grid technology really opens the door to a faucet of various different advantages for the fleet.
So the vehicle to grid technology for me always sounds so futuristic, and it sounds kind of like this, wow, how could this happen? There's so many sort of different parts that need to be connected. Is it actually happening today, or is this something that's really feasible and that businesses can build into their EV deployment plans?
100%. So this is happening today. Geotab's directly involved in a number of projects. The only thing I would say the fleets need to be cognizant of is the vehicle itself should be V2G capable. And if that bidirectional power flow is available on the EV, it's super easy to pair that up with a charging station and its functionality to then facilitate that exchange of energy with the grid.
Okay, and so Mary, at Purolator, where you might want this flexibility, you might want this opportunity to bring down some of your costs. You have a large fleet. You're going to have a lot of power being drawn from those vehicles. So, have you guys considered V2G technology as something that you'd like to incorporate?
Maddie, we are still learning, and we're doing pilots right now. So we will be partnering with Geotab and other organizations to help us reduce those costs associated with our transition to EVs. It's very new to us and to a lot of different fleets out there. So yeah, we're still very early stages, but absolutely looking at all alternatives that are out there.
And so, I mean, kind of going off this idea of wanting a bit more redundancy or connectivity, there is a concern for some fleets that what happens when the grid goes down? Like, what do I do? How do I get power to my vehicles? So, how is Purolator mitigating that, Mary? Like, what solutions have you put forward to mitigate that risk?
So one that we are exploring right now is the potential of using our fuel burning, like diesel backup generators. Actually, we're transitioning to natural gas generators in our new national super hub. And so the idea being to exercise those generators, which is always a good idea, just in case you ever need to use them, you know that they're going to function the way you need them to. But also in case there is a power disruption, that we could use those generators to charge the fleet so that there won't be any disruption to the fleet operations. So there are contingencies and things that we can do proactively to make sure that if there happen to be any power disruptions, that we're prepared, we're ready for it.
Yeah, absolutely. I think building that redundancy is critical to mitigate some of these risks. Sid, did you have something to add there as well?
I did, and this is just generally is a simple strategy that fleets can deploy for overcoming the hurdles we just spoke about. Vehicle to grid, managed charging, these are slightly advanced concepts, but sometimes what fleets can do that is really simple and super effective is introduce, and this may not be applicable in all cases, but definitely, we're seeing a number of Geotab partners start to put into place some of these practices, and that is just at-home charging reimbursement. So this is when an employee takes home the vehicle and charges it at their home instead of charging it at the local facility. And what that does is it just you avoid the scenario where everyone is done their shift or the duty cycle's finished at say 5 p.m. and then all EVs get plugged in and you automatically run into demand charges. This way you offset the charge to a different utility, perhaps if the employee lives far away from the facility. And it's easy to introduce today. You can put into place a flat rate reimbursement system, and it really helps you manage the load on the grid at the facility.
I think that's such a smart idea. I mean, we really kind of honed in on the depot charging return to base operation kind of segment for our research, but there are so many companies out there right now that are sort of relying on contract workers and taking advantage of the gig economy where people might have the opportunity to, or they might own their own vehicle as well. So there are opportunities to do that kind of take home charging. So I also want to talk about some of the other ways that fleets can, or different strategies to reduce costs associated with this transition to EVs. While we have shown in our research that fleets can expect to experience benefits after about 7 to 8 years, we know that there are some really high upfront capital costs that fleets may face. So what are some of the different solutions that can help reduce those costs? I know smart charging, vehicle to grid technologies, those are two of them, but are there any other sort of ideas that you have on or recommendations to make? Mary, why don't you kick things off here?
Well, you talked about the upfront costs. So I can tell you that the cost for a curbside delivery vehicle, for example, is roughly 3 times for an EV version, 3 times the cost of your traditional internal combustion engine vehicle. So there is quite a large upfront cost that we've seen. And again, we're looking to all of these, vehicle to grid opportunities to save some costs, but just really understanding the vehicle and the technology now. And again, this time is really exciting because there are so many new technologies coming out, and we're seeing a lot of even Canadian solutions coming onto the market, and you know, the government has a lot of really great initiatives going on to support clean tech adoption and acceleration to help us with that. But it's just an exciting time that technology is only getting better, and the costs are going to be coming down. It's just making sure, you know, being part of the early adopters and testing the technology, and just, you know, really doing our part to get it out there first to do our part to reduce greenhouse gas emissions.
Absolutely, you're making it easier for other fleets that are following along the way. So I think one of the concepts too that I've kind of heard of, and I think Sid, you'll be able to speak to this a bit, is this idea that it's an EV deployment is an opportunity as well to look at, excuse me, I've got some sirens out my window here. It's an opportunity to take a look at all of your operations and to sort of optimize your fleet. So there's this kind of concept of developing minimum vehicle utilization standards. So this idea that, you know, you might have 3 vehicles performing deliveries one day, but you actually, in reality, upon reevaluation, might only need 2. So Sid, I mean, have you kind of experienced that, or is that one of the benefits that you've seen working with some fleets at Geotab?
Absolutely. We 100% work with fleets to come up with a minimum utilization, like you said, to ensure that the vehicles are operating in a manner that is overall efficient holistically, right, at a higher level. So you really want to zero in on what those duty cycles are individually, and look at how can I take advantage of all the different places where I can monitor data to ensure that I'm operating my fleet efficiently. So one example of this is taking advantage of daytime dwelling times. So these are times when the vehicle isn't necessarily in a duty cycle. It's within the day, it's not at the end of the shift, but they're not actively making deliveries. We find that a lot of our fleet partners are not taking advantage of being able to charge, even though they have the opportunity to do so. And it's just because they haven't zoomed in and found out that, hey, I have an opportunity here to extend the range of my vehicle just by taking advantage of some more daytime charging. And all of this is really enabled through data. And what this speaks to at a high level is to basically use your data and technology to be on top of any opportunities you do have for optimization. So an example of this would be, we do run into scenarios we've seen where fleets make it back to home base at the end of the day, but they forget to plug in, they forget to charge. So you can really use some data and automation to say, send you an alert every time you've entered your home base, using a telematic system that looks at geofences. You can say, hey, I'm back at my home base. It's been 10 minutes, but I haven't plugged in my EV yet. Send me an alert, or send the fleet manager an alert, to basically stay on top of these opportunities that might not be obvious to you at a holistic level. Like, you really want to zoom in, you want to look at each duty cycle individually, and then optimize where you can for charging and for vehicle utilization as well.
And so, yeah, I imagine, I spoke to kind of vehicle utilization specifically, but I imagine taking advantage of kind of like that opportunity charging also gives you an opportunity to minimize the number of chargers that you need to buy. So if you can do so during some dwell time in the middle of the day, it might mean that you don't need to do so overnight, and you don't actually need a 1-to-1 charger to vehicle ratio. Okay, so I want to make sure we're keeping our audience engaged here. So I'd like to put out another audience poll. So given what you've heard around the costs and benefits of EVs, as well as sort of what fleets need to do to deploy EVs, what steps do you see as being most critical to accelerating EV deployment for urban deliveries in Canadian cities? So A, financial incentives for commercial EV procurement. B, scaling up commercial EV manufacturing to ramp up vehicle supply. C, an electricity rate class that supports low-cost overnight EV charging, so that gets at some of those demand charge issues. Or D, non-financial incentives at the municipal level. So this would be things like low emission zones that regulate the types of vehicles that can come into certain urban areas, or curbside management tactics as well that can incent the adoption of EVs by allowing preferential access to low emitting vehicles. And so I will note you can select as many of these as you like, but we really want to get at sort of what are the most critical steps here. So I'll give you all just about 20 seconds more to respond to the poll. I know this is a difficult one. We're at early stages, so I think, you know, there are a lot of supports that we need to discuss and need to deploy. All right, let's take a look at those results. Okay, so we've got up top, the top response here at 61%, financial incentives for EV procurement, but everything is actually pretty close. Scaling up EV manufacturing electricity rate classes to avoid, or to aid rather, low-cost overnight EV charging and some of those non-financial incentives as well. So what I'm hearing from the audience is we really need to all hands on deck here. Okay, so I mean, Mary, getting at this sort of financial incentives piece here, you know, BC is the only region here in Canada that offers financial incentives for commercial EV procurement. You know, while we do have federal incentives for passenger vehicles, those don't apply to commercial vehicles. So I'm curious, you know, did that play a role in Purolator's decision to deploy EVs in Vancouver?
So financial incentives exist, you know, where we introduced our fully electric delivery vehicles, like you said. But unfortunately, in our case, it came into effect after we'd already placed our order, but it does influence, you know, where we deploy, absolutely. And so for some of our other, you know, pilots, the e-cargo bikes, for example, and low-speed vehicles, having incentives absolutely plays a role in the decision where to deploy our EV pilots. In the case of our Richmond facility, where we deployed the fully electric vehicles, the other reason for selecting that area in BC is also it was in closer proximity to our vehicle manufacturer in California. So the motive conversion kit, that's just having that proximity to and the training so that we can also leverage the technicians and the skills to transfer that knowledge over to our team in Richmond was very important in the decision making.
And Sidis, have you seen any correlation among the fleets that you work with between sort of the availability of incentives and electrification opportunities?
Sorry, I was unmuting myself there. Yes, actually, we've seen a lot of EV fleets start to pop up, or existing fleets starting to deploy EVs almost exclusively in the state of California. And there's so many projects there that we're involved in, and the main driver for those is the California HVIP program, which provides a financial incentive to fleets looking to deploy an electric vehicle, but it's actually implemented at the OEM level. So the OEMs can provide their end customer with a discount because their vehicle was operated in certain regions in California. And we're finding that this is such a driving force for EV adoption that really I encourage us to replicate the same in Canada.
Absolutely, yeah, I think there is a strong correlation, absolutely, that we're seeing between some of the availability of these incentives and actual EV deployments. So I'd also like to look at some of the other levels of government. We have a number of representatives from municipal government in attendance today. What would you like to see from Canadian municipalities in terms of their support? Mary, let's start with you on this one.
Well, I have my Christmas wish list all ready to go here, and they can be characterized into 4 major buckets. So the first one being regulatory measures. So under regulatory measures, you know, decreasing time and access and street restrictions, reviewing parking regulations for green deliveries, eliminating tickets for green deliveries, and reducing environmental restrictions for hybrid and electric vehicles, and then reducing size and load access restrictions. The second category would be for land use planning and infrastructure. So adapting on-street loading zones for green deliveries, establish nearby areas for in-city deliveries, and then increasing e-cargo bike lane and street accessibility. The third bucket is for urban consolidation centers. So exploring opportunities to pilot and establish microhubs in dense urban areas or zones with high truck volumes, and then also providing financial support to offset the high, estate cost of micro hub space. And my last sort of wish list item is in the area of green fleet development. So reviewing and updating the zero emission fleet definition, regulation and acquisition restrictions like for e-cargo bikes, for example, and then exploring policies and incentives to encourage uptake of zero or low emission delivery vehicles at the local level. So having, EV purchase incentives.
You've definitely got a wish list there, Mary. I love it. Now, say it quickly. I know Mary's covered a lot of it there. Do you have a couple of things to add to that? Just super quickly, I do want to get to a couple audience questions, and we only have about 8 minutes left. So over
Absolutely.
to you for a quick response.
Yeah, so I honestly, Mary's list was so comprehensive. It covered every single point I had on my list as well. Just for emphasis, I just want to say, yeah, definitely we can encourage our municipal government folks to introduce low emission zones and preferential parking. I think this opens the floodgates to everything else Mary said, right? We're seeing this in a number of regions in Europe. And from there, you see different adjacent EV adopting incentives spin out. And really, I just want to emphasize those.
The power of non-financial incentives. Yes,
right?
Absolutely. Yeah. Okay, so we've got a few audience questions here, and I encourage the audience to put in any sort of other questions they might have for our panelists today into the chat box there, or question box rather. So one question that I want to get at from the audience is, I'm not sure actually if it was Mary or Sid, one of you mentioned this idea around like key data points and KPIs that you need to track during EV deployment. What are some of those KPIs? What might they look like?
Yeah, I think I mentioned it, so I'll jump in. So some of the key KPIs is looking at how and where, when, and for how long you charged. So having a means to look at your charging history or looking at your charging in real time, so you can actively manage it, actively or retroactively manage it. I think that's a very, very important KPI, because that is directly relating to answering the question, how much does it cost me to power up and operate my EV fleet? Another really important KPI is looking at the efficiency of the vehicles. What is my kilowatt hour to mile ratio looking like? And am I really optimizing that? Can I maybe leverage technologies to drive that up, to drive my efficiency higher? So influencing, for example, driver behavior, also influencing the types of charging you do. And what I mean by that is if you have an electric vehicle and you constantly DC fast charge it, what actually happens, and Geotab does study on this, is you degrade your battery at a faster rate. So being cognizant of how much you DC fast charge, or knowing that, okay, hey, it's inevitable, I need to DC fast charge, but making plans to maybe swap out your battery for a fresh battery at the 5-year point would be an equally important KPI. And yeah, I think those are the main ones I'd like to highlight.
Wonderful. Yeah, that data on your energy consumption, how it's being used, how it is being, how you're going through it, I think it is critical. Mary, do you have any other sort of things to add to that KPI list?
Well, it's interesting. So the new vehicles that we've deployed in Richmond, they're going to be participating in the Run on Less electric demonstration that's being put on by the North American Council for Fuel Efficiency. So we will be sharing, the KPIs that are being measured. So again, to share with everyone, how these vehicles are performing for us, and absolutely like in our climate too, which is also important in our environment.
Wonderful. Yeah, absolutely. Okay, so we've got a question here around, actually probably more directed at our analysis here, but whether or not our fuel cost savings include the escalating carbon tax. And just to clarify, it does not. So we actually found that there are cost savings without even taking into account this carbon tax, and that there is a reasonable payback period for these vehicles without that consideration. But I know for a lot of fleets, this is a big thing. And so, I mean, Mary, do you want to maybe speak to this app or the Purolator perspective on this a little bit?
Actually, when you were presenting, we were in line with your calculations as well. So yeah, and we also didn't factor in the cost of carbon. So yeah, we're in line with our longevity of our vehicles is 10 to 12 years, and the payback 7 to 8, I think, is also what we came up with.
Yeah, I think it's a great thing that you know, the payback period is so reasonable, but if fleets want to consider in that carbon tax as well, like, it's only going to get even more reasonable.
Mm-hmm.
So I've got another question from the audience here around plug-in hybrid options for delivery vehicles. So I know, you know, the vehicle supply for EVs is still somewhat low. You know, it still might take you a couple of years to get your hands on a vehicle. So, you know, Mary, I think, and Sid, I'm sorry, I'm directing both of these questions here at Mary, but I know Purolator has some hybrid options. Did you consider the switch to plug-in hybrid vehicles, or were there certain sort of advantages to going straight to EVs?
So with it's funny, our history with the hybrid electric. So we're not new to this space. We introduced our first hybrid electrics in I think 2005, and with the you know, thought and hope to increase this across our fleet. Unfortunately, in the Canadian space, in manufacturing, that particular outfit that we used, they went out of business. So again, having those incentives to support the manufacturers of this equipment will also help us. So we're just, you know, EVs is, we just wanted to take that leap and get into that space instead of exploring more into the hybrid space. So really wanting to look at, you know, expanding not only our e-cargo bikes and low-speed vehicles, but really looking into new electric delivery vehicles for our 18-foot electric curbsides, as that's going to make a huge impact on our emissions and our Scope 1 profile.
Yeah, absolutely. Sid, did you have anything to add there? I know it's a little bit out of your wheelhouse, perhaps, but if you do, I want to give you the opportunity.
Yeah, the only thing I wanted to add is when and it's sort of linking it back to the previous question about KPIs, is when you do operate hybrid electric vehicles as opposed to full battery electric vehicles, you're running into a slightly different set of KPIs. The most important of which is ensuring that during the operation in certain zones, for example, places where there's a lot of congestion or city centers, you want to ensure that your hybrid vehicles are operating in EV mode when they're in those congestion areas. And that's something that fleets must definitely you know, be cognizant of if they have hybrids in their fleet.
Absolutely. I think the benefits of, you know, an improvement to the local air quality that those plug-in hybrids they present is so important. I was very happy when I discovered the EV mode on my mom's hybrid, I must say, on her Prius. Love that that's an option. Okay, so I think we're actually out of time here, but I'd love to thank you both for being here today and sharing your insights. You know, you both have a wealth of knowledge on EVs, urban deliveries, charging infrastructure deployment. So I really, really appreciate you being here and sharing your insights. And with that, I hope everyone has a great day. Thank you to all in the audience who have attended.
Thanks for having us, Maddie.
Thank you.